What's going on, guys? Welcome back to another video, and in today's video we'll be going over the Fibonacci sequence in Python. In my last video about recursion, I challenged you all to program the Fibonacci sequence, and today we're actually going to do it, so let's get right into it. So if you're unfamiliar with the Fibonacci sequence, it is a series of numbers in which each number is the sum of the two preceding numbers in the sequence. So for example, the Fibonacci of 0 is 0 and the Fibonacci of 1 is 1. That's just to get the ball rolling. So we really start the Fibonacci of 2. And the Fibonacci of 2 is, as I stated, the sum of the two preceding numbers in the sequence. So it is the sum of the Fibonacci of 0 plus the Fibonacci of 1. So it's 0 plus 1, which is 1. So the Fibonacci of 3 is the Fibonacci of 2 plus the Fibonacci of 1. So it's Fibonacci of 2 is 1, the Fibonacci of 1 is 1, so the Fibonacci of 3 is 2. And we just keep doing this pattern over and over again, right? So let's actually program this. So let's define a new function called fib. It's going to take in the value n. And like I mentioned in my recursion video, every recursive function has to have a base case. But what is the base case for this function? Well, when we input the value 0 in here, what do we want the return value to be? Well, based on this sequence, we want the return value to be 0. What about 1? We want it to be 1. And once we get to 2, that's when we start doing the mathematical formula. So I'm going to do is I'm going to say if n is less than or equal to 1. So in this case, if n is 0 or 1, I want to return n, right? So if it's 0, I want to return 0. And if it's 1, I want to return 1. Anything else, I want to actually do the formula. Well, what is the formula? The formula is, what we're going to put here is n minus 2 plus n minus 1. So the Fibonacci of n is the Fibonacci of n minus 2 plus the Fibonacci of n minus 1. That's the mathematical formula. That is literally what we're going to put in here. So we're going to return the Fibonacci of n minus 2 plus the Fibonacci of n minus 1, right? And that's literally the mathematical formula. Okay, so let's try this out. Let's print the Fibonacci of 5. So this should be 5 based on the sequence, and it is. And if we do the Fibonacci of 6, it should be 8, and it is. Now, let's look at the trace diagram for this recursive function. So I created a little diagram here. This is called a tree. And say we input the Fibonacci of 5, right? So we input 5. You may notice that it goes into two different directions. And that's because we're calling the fib function twice. So it's calling n minus 2 and n minus 1. So one direction is going to be n minus 1, which is the Fibonacci of 4. And the other is going to be the n minus 2, which is the Fibonacci of 3, right? And it's going to keep doing this all the way until it gets down to either 1 or 0. All right. And what I have written in red here is the result of each function. So each Fibonacci function call is going to return what's in red. And we're going to always start from the bottom. As I mentioned in my last video, this is a stack. So the last item on the stack is the first item out. Imagine you're stacking plates. This last plate that you stack is going to be the first one you take out, right? You're not going to take one from the bottom. That's just not what you should do. So we're going to start from here. These are going to be the first return values that are returned, not up here. It's just going to go up this little tree here, all the way until we get back to the Fibonacci of 5. All right. So that's all we're doing. And you may notice that if we get to a large enough values, this could be really, really slow. Like right now, we're only dealing with small numbers, 5 and 6. Imagine I put in 60 here. Would this even print out? It wouldn't. This is going to take forever. Like we could just sit here for maybe hours and this won't run. So I'm actually going to kill this because it's going to take so long. But yeah, this is an issue. We cannot do the Fibonacci of 60 with this current code. And the reason for that is, now imagine I inputted the Fibonacci of 60 instead of 5, right? So each of these little circles or function calls is known as a node. The Fibonacci of 60 will have so many nodes that it would just take forever to run, and it would be so many different computations that the computer would have to do, and it's just not optimal. Now, there is a solution to this, and I'm not going to go into detail about the solution in this video, but I will just talk about it briefly. We can, for example, we have the Fibonacci of 3 twice here. Instead of having to do the computations of the Fibonacci of 3 2 times, I could just store the Fibonacci of 3 inside of a data structure and then call it when I need it. So I won't have to do it twice, I'll just have to do it once and call it when it's needed. So that's just the brief overview of how you would implement a faster solution. And I'm actually going to do that in my next video. So not in this video, in my next video, we'll go over how to make this Fibonacci sequence function more optimal. But that will do it for this video. If you enjoyed the video, make sure to like, comment, and subscribe. And I hope to see you in the next one. Take it easy.